we're going to take a look at 2.3b, solving for y and naming the slope and y-intercept. So we're going to be graphing these equations eventually, and we want to make sure that we can pick out everything that the equation actually tells us. And in this particular case, when we're drawing these nice linear lines, it's going to tell us two things. One, the slope, and one, the y-intercepts. We've got to be able to name them and pick them out to help us go ahead and graph them. So solving for y is really the same step that we've been doing for a while now. We did this with literal equations, right? Solving for a variable. In this case, I'm solving for y. And we did it, we just finished doing it in 2.3a when we were solving for y, when that was our goal, okay? So we're going to solve for the y, which means I need to get rid of the 2 and I need to get rid of the x. So I'm going to get rid of the x first, so I'm going to move the x, subtract x from both sides. When I subtract x, I get 2y on the left. 6 minus x, I'm going to write that as negative x plus 6. Okay? So I could do 6 minus x, and we'll do that on number 2, but for right now, we're going to leave that as negative x plus 6. So then I need to get rid of the 2. Well, that's 2 times y, so I'm going to divide. So I divide by 2, divide everything by 2. There's a lazy 1 in front of that x, so this is negative 1/2 x, and then 6 divided by 2 is 3. Okay? So here's my solving for y. Step 1, done. Negative 1/2 x plus 3. So then we need to pick out the pieces of this graph or this equation that will help us graph. And so we look at that general form as being what's called slope-intercept form, because it's going to tell us the slope and the y-intercept. And that general form is y equals mx plus b. And that m and the b could be plain numbers in terms of positive whole numbers. They could be fractions. They could be negative whole numbers. They could be almost anything that you want them to be. Okay? But well, in our particular case, the slope is generally going to be the fraction, and the y-intercept is generally going to be a nice whole number for us to be able to graph it. Now, that doesn't always happen, and it isn't always the case. But if in most situations, because we're in math class, that will happen that way. So then you ask, well, what's the x and the y? Well, the x and the y is just a point on the graph, okay? A number that I can plug in. I can take a number for x for the domain and get a number back y for the range. The slope is the m and the b is the y-intercept. So the m is with the x and the b is by itself. So when I go back here and I look to name the m, the slope is negative 1/2, the number in front of the x. Okay, that x term is called a linear term. Okay, and so the number in front, the coefficient of the linear term, is the slope. So then the b was the number at the end. This is a positive 3. You do not need the positive there, but it will be helpful to know that that is a positive 3 when we get to graphing it. Okay, don't forget about the sign in front of that number. And that number is called a constant because it doesn't have a variable with it. It's called a constant. So then number 2 here, let's go ahead and solve it for y. So that means I'm going to move the x, so subtract 3x. And just like I told you on the last one, I'm going to write this in the opposite way, the second way that you could write this. So I can write this as negative 8 minus 3x, and that's perfectly fine. I also could write it negative 3x minus 8, and that would be okay too. Dividing by 2, because I need to get the y by itself. So y is equal to negative 4 minus 3 halves x. That's my solving for y step. Okay, so I'm done. Y is solved by itself. Now I need to name the slope and the y-intercept. The slope is the number in front of the linear term. Okay, so the number in front of the linear term, or the number in front of the x, is negative 3 halves. And the b is the constant, the number that's by itself. That's a negative 4. You have to have the negative there. Okay, you did not have to have the plus on number 1, but you have to have the negative on number 2. Number 3. So I've got y equals 6. Oh my goodness, there's no x, but the y solved by itself, so that's good. Okay, so I'm already done doing the solve for y part. But I need to name the slope and the y-intercept. So there's no number with the x. So my slope is going to be 0. Another way to think of that is I've got 0x's plus the 6 that's there. So I've got 0x, so my slope is 0. And I've got a 6 for the y-intercept. The b is equal to 6. Again, it might behoove you to put a plus in front, but you do not have to. It can just be 6 and that would be fine. Here's where the system falls apart. Number 4. So I've got x is equal to negative 4. There's no solving for y. I can't solve the equation for y. So what do? I just realized that this line doesn't follow the rules as every other one. So the slope in this one is called undefined. Okay, it doesn't follow the rules. It's undefined. Okay, which then means that I've got a b-intercept that, or a y-intercept, a b that doesn't exist. Okay, so I put there is none there. Okay, so undefined and none. We've got x is equal to negative 4. That's an undefined slope. Okay, and we'll talk a little bit more about what that means. And the y-intercept says that, that there is none there. Okay, so going through, we're picking out the things, recognizing that that x equals equation has a goofy situation. I can't solve for y, so there must be something else to it. Okay, and we will learn about that as we continue graphing. Ask questions as you have them when you finish up this worksheet 2.3b.